All right, so today we're going to move on to our next lesson, and it's going to be how to calculate molar mass. That's going to be something we utilize a lot more in our lessons for next week. But like I said, we're going to kind of break it into manageable pieces. And so for today, you need two things, a periodic table and a calculator. Your periodic table, if you can get your hard copy version out, otherwise go ahead and open up an electronic version if that's an option for you. So if you don't have those two things out, I would recommend pausing it real quick and finding those two things and then starting the video back up. So we have used a lot of pieces and components of the periodic table throughout the year. The one thing we haven't used is atomic mass. That's the number found at the very bottom of the box of the element with the style of periodic table on my screen, and also with the periodic table you guys have in front of you. For the most part, periodic tables are pretty standard in that it's usually found at the bottom. And so what that tells us is it's now talking about grams. So we talked about atoms and molecules and how that relates to the mole. Now, most likely we can't go back to a lab and count out individual molecules of sodium or individual molecules of water. And so grams is something we utilize a lot more when we start talking about mole conversions. And so right now, the big thing I want you guys to be successful with is how to set up the conversions. We'll get into why does the mole even matter, because this is basically a very big topic for chemistry. All the solutions that you guys have used in lab and those different resources, we have to do mole conversions to figure out how to mix them properly. And so what we're going to work on today is mainly how to find the molar mass of something that's a compound. So if I ask you for the molar mass of an element, those are really easy. You just go to the periodic table, look up the symbol, whatever's at the bottom is its molar mass. So what we're going to work on, like I said, is how to find the molar mass of something that's in a compound. So the kind of components that you need to do to figure this out is that you need to know how many of each element you have in the formula, and then you have to look up their individual masses and get a grand total. And so I'm going to walk through 3 examples, and that should help you figure out how to find molar mass of something that's a compound. So in this first example, it wants to find the molar mass of water. Well, I kind of was hoping you guys would realize you don't have a chemical formula, but you should know by now that the formula for water is that it's H2O. So what you need to do first, and this is how I like to start out doing molar mass to make things easier, is you take an inventory, kind of like with balancing. So we list out what we have. We have hydrogen, we have oxygen. The next thing I do is I count how many I have based on my subscripts. I have 2 hydrogen, I have 1 oxygen. Now you're going to go to your periodic table. So when you utilize your periodic table, we're using the atomic mass found at the bottom of each element's appropriate box. When you go to hydrogen, it says 1.008. So the first thing we're going to do is I tell you guys just to round the atomic mass off to 2 decimal places. And the one thing that across the board in my time in chemistry is hydrogen, we just round it to 1. So we just say that hydrogen has a mass of 1. So because we have 2 of them, you multiply it by the molar mass of hydrogen. And then we're going to do the same thing for oxygen. So if you go to oxygen's box, you find 15.999. Well, those 9s are going to round it. So oxygen has a molar mass of 16. So mathematically what we need to do to get our grand total is we're going to go ahead and multiply 2 hydrogens times its mass of 1, add that to the 1 oxygen with its mass of 16. So that gives us a grand total of 18.00. This is a unit, grams per mole. That tells us to have 1 mole of water, you must have 18 grams. So if you had a scale at home, you could get a cup, account for the mass of the cup, and get 18 grams of water from your faucet, and you would have 1 mole of material in that cup at that time. Okay? So my next example is lithium carbonate, and I give you the formula Li2CO3. Like water, the very first thing that you do is take an inventory of what you have. We have lithium, carbon, and oxygen. The next thing is you need to know how many you have. We have 2 lithium, 1 carbon, and 3 oxygen. You multiply the quantity of each type of element times its individual mass from the periodic table. So when I find lithium, I find that it's 6.941. Again, we can round this to 2 decimal places, so we can say 6.94. Carbon on your periodic table is 12.011, so we're going to use 12.01. Last one, oxygen, we just used on the previous example, that 15.999. So again, we use 16 there. So your next step is, again, you're going to multiply and add these up. So the one thing that's nice about molar mass is you can put this all in your calculator at once. So you can take 2 times 6.94 plus, and you don't really need to do that times 1, but you can put it in there if it makes it easier on you. 1 times 12.01 plus 3 times 16. Again, you could do these in 3 separate multiplication steps and then add, again, either one. It's not really an issue with order of operations on these particular calculations. So my answer to 2 decimal places, I got 73.89. That unit again for molar mass is, this is how many grams are in 1 mole. So each compound and element have their own unique number. So water, you only need 18 grams to have a mole of it, versus for this lithium carbonate, you have to have 73.89 grams to have 1 mole of this material. One last example that I have for you is just kind of working on getting a little bit more intricate in terms of what you have to account for, is a polyatomic, and we have parentheses. So just like the other examples, we have to break this apart, unlike in balancing. Like if we had a polyatomic on both sides, we could account for that and count it as a unit. Now here with molar mass, you have to separate them all out into their own individual element masses. So we have aluminum, sulfur, and oxygen. Aluminum's pretty easy. It's not in parentheses, so we have 2 of them. If you remember, this is much like your math. With these parentheses, we distribute in. So this 3 multiplies to each of these. So we're multiplying. Because there's nothing next to sulfur, that's implying 1. So I'm taking 1 times 3. So there are 3 sulfur. Oxygen, I have a subscript of 4 and that 3 outside. I multiply it in. There are 12 oxygens. Oxygen we've used now in the last 2 examples. So again, its individual mass is 16. We need to look up sulfur. We need to look up aluminum. Aluminum on your periodic table is 26.982. We can round that off and say 26.98. Sulfur is 32.066. So we can say 32.07. We're going to go ahead and multiply 2 times 26.98, add that to 3 times 32.07, and then add that to the last piece of 12 times 16, and you get a grand total of 342.17 gram per mole. Notice that went up a lot more. So you have to have more mass for this particular compound to have 1 mole of it, because we're working with more atoms with different atomic masses versus water and the lithium carbonate. So all I have for you guys to do for the remainder of this assignment is to do those 3 practice problems. Like we've done, you have 3 uploading options. You can work this out digitally and turn it in as a Google Doc. You can print it and send a picture, or you can take it on your own piece of paper, take a picture and upload it. So whatever your personal preference is, whatever works for you, works for me. And I hope you guys know that if you have any questions, needing any help, please reach out to me through Google Hangouts or send me an email, and I will get back to you.